All right. So now for this one, it says convert the velocity vector 9, comma 5 into polar coordinates. So polar coordinates is like going through the origin. So whatever this vector is, it's going to go 9 units in the x direction and 5 units in the y direction. So it doesn't matter where you draw it in space. I'm going to draw this, well, that's not a very accurate one. Basically, what I'm going to do is I go 9 units in this direction, and then I go 5 units in the positive y direction. And so my overall vector would be this right here. So this is my velocity vector that is 9, comma 5 meters per second. Now what they really want to know is we need to put it into polar coordinates. Okay? So what they're saying, polar coordinates, they're talking about like how does this thing live in the xy plane? So if I think of the xy plane, how do I determine the magnitude and the angle? So really what they want to know is if I draw this in the xy plane, what is the magnitude and what is the angle? And so the angle is from here to here, and we'll call that theta, right? The Greek letter theta. Also on the xy plane, if we're starting from the origin, there's some information that we need to know. Sometimes it makes it easier. But that point right there is 9, comma 5. Okay, the tip of that magnitude. So I need to know the length from here to here. That's the magnitude. Well, I can calculate that, right? So it's a velocity vector. So does anybody remember how we figure out the velocity vector? Well, when you think about this, this is v sub x, and this is equal to v sub y. So what's the formula to find v, the magnitude? Well, you haven't memorized this yet, but in your notes you should have this written down. V sub x squared plus v sub y squared. So the magnitude is just going to be 9 squared plus 5 squared, which will be equal to the square root of 81 plus 25. Okay. What is that? 106. Now, I'm going to plug that in the calculator real quick. It should be pretty close to 10. Oh, I see why. Keep hitting the wrong button. Yeah, so it's about 10.2. Now, based on the fact that they're rounding this, if we use significant figures, we would just round that as 10. So we would say this velocity is just 10, based on significant digits. Okay. So meters per second. So we found the magnitude. Now how do we find the angle theta? Well, you also have that formula too somewhere in your notes. You just got to look them up. To find theta, right, I need the arctan of v sub y over v sub x. And this you just plug in the calculator. So I'm going to say theta is equal to arctan of 5 divided by 9. And so there's a button on your calculator, and you can pull it up anywhere actually. So if I pull up my, you could do it in Desmos, you could do it on, but any scientific calculator, right? So if I use any scientific calculator, it would be over here, but we need arctan. I might have to do it on Desmos. So let me pull up Desmos real quick. This is what you guys have. I'm going to do it on Desmos because that's what you guys have to use. By the way, Desmos is what they use for the SAT. So probably it's in your best interest to use Desmos all the time. Shoot. Well, go to function. There it is, arctan. Then I'm going to go back here and say 5 divided by 9. I want to make sure that I'm in degree mode. I am, because degrees is selected. I get 29, oh, it's about 29 degrees. That's what that 29 means. So this, so it's about 29 degrees. So this right here is about 29 degrees. Is that one of the options?
Yeah.
Does that make sense to you guys? Does anybody have any questions on that? Okay.